Today we'll be doing the integral from 0 to 1 of x divided by 1 plus the square root of x dx. And to start, we will consider the more generalized integral. We will consider the integral from 0 to 1 x to the b minus 1 over 1 plus x to the a dx. And we use the following fact that 1 over 1 plus x to the a is the sum from 0 to infinity negative 1 to the k x to the ak. So we end up having the integral from 0 to 1 x to the b minus 1, and then the sum from 0 to infinity negative 1 to the k x to the ak dx. And then swapping the sum and integral, we have the sum from 0 to infinity negative 1 to the k, and the integral from 0 to 1 x to the ak times x to the b minus 1 dx. And now combining the exponents, we have the sum from 0 to infinity negative 1 to the k, and the integral from 0 to 1 x to the ak plus b minus 1 dx. And then integrating this and evaluating it from 0 to 1, we will end up having the sum from 0 to infinity negative 1 to the k, and then x to the ak plus b over ak plus b from 0 to 1. So now we have that the integral from 0 to 1 x to the b minus 1 over 1 plus x to the a dx will end up being the sum from 0 to infinity negative 1 to the k over ak plus b. And now if you split this sum into its even and odd parts and relate this to the digamma function, you will end up seeing this is going to be 1 over 2a, the digamma function of a plus b over 2a, then minus digamma of b over 2a. And we're interested in the case when b equals 2 and a equals a half. So this will end up being the integral from 0 to 1 x divided by 1 plus x to the 1/2, which is the square root of x dx. And plugging in this values into this expression, we have 1 over 2 times a half, digamma function of 2 plus a half, and then 2 times a half minus digamma of 2 over 2 times a half. But as you end up seeing, these will just end up canceling. We have that the integral from 0 to 1 of x divided by 1 plus the square root of x dx will end up being digamma of 2 plus a half minus digamma of 2. And we could rewrite this as digamma of 1 plus a half minus digamma of 1 plus 1. To find the values of these digamma, we will use the following recurrence relation, and that is that digamma of x plus 1 is digamma of x plus 1 over x. And we use the fact that digamma of 1 will end up being negative Euler's constant, and that digamma of 1/2 is negative 2 log 2 minus Euler's constant. So plugging in 1 here, we have that digamma of 1 plus 1, which is digamma of 2, is digamma of 1 plus 1, which is negative Euler's constant plus 1. So we have that the integral from 0 to 1 of x divided by 1 plus the square root of x dx is digamma of 1 plus a half, and then minus digamma 2, but we said that's negative Euler's constant plus 1. And this will end up being digamma of 1 plus a half plus Euler's constant minus 1. And now we use the same recurrence relationship on this one. So we'll end up having digamma of 1 plus a half plus 1 over 1 plus a half plus Euler's constant minus 1. And we will do it again. So we have digamma of a half plus 1 over a half plus, this will end up being 1 over 3 halves plus Euler's constant minus 1. And we said that digamma of a half was negative 2 log 2 minus Euler's constant. 1 over a half is plus 2, and 1 over 3 halves is plus 2/3, and plus Euler's constant minus 1. But as you can see, the Euler's constant ends up canceling, and 2 minus 1 is 1. So we have negative 2 log 2 plus 1 plus 2/3, which will end up being negative 2 log 2 plus 5/3. So now we can say that therefore the integral from 0 to 1 of x divided by 1 plus the square root of x dx is negative 2 log 2 plus 5/3. And so this is the final result.